Hi everyone. So we're going to just look at a bit of an introductory to angles really, with starting out with a straight line and looking at triangles by the end of the video. So the first thing we really need to be kind of confident and sure about in this topic is that angles on a straight line add up to 180 degrees. And there's my straight line, and using a protractor, if I pop it on there, you can see if I start here at 0 on my outside scale, it's all the way around and it ends at 180. Okay, so regardless of what types of angles I've got on there, I might have an angle over here, and I could have perhaps something coming up here. Okay, I could have these three angles here. I know that those three angles, whatever they are, have to add up to 180 degrees, because if we're on a straight line, they always must add up to 180 degrees. So that said, we're going to look at this experiment I've got here with a triangle. Okay, so I've drawn a triangle, and you can do the same. And this is just a sketch of a triangle. I've not traced it, I've not measured anything, I've just put a ruler down and drawn a triangle. Okay, so if you all do this at home as well, you are going to end up with different triangles, and actually that's even more proof that this works. So I'm going to cut out the triangle, just like this, as neat as you can, because of course if we get a little bit unneat, that's when it starts to be not quite as precise as we'd like. And the last line here. Okay, so here's my triangle, and the first thing you need to do once you cut it out is to label these angles. It's really important that you label them, because in a moment we're going to cut the whole thing up, and if you've not labelled your angles, you'll forget which part is the angle and which isn't. So I'm going to call them X, Y and Z. You can call them anything you'd like, but I'm going with X, Y and Z. So once you're to this point, pause if you need to so you can catch up. But what I'm going to do, now watch carefully, I'm going to chop each angle so it's separated from the rest. Now, you don't have to be particularly precise, as long as your angle's, not cut in half. I'm going to chop the X angle off. Okay, so I'm left with something like this. And then I'm going to chop, so X, Y and Z are separate as well. Okay, so I'm just going to chop straight up the middle like that. So I've got three separate pieces, and you can see my three angles. And this is why we labelled the angles. We don't want to get confused about where they are. I'm going to draw a new straight line. I don't want to use the one we've just used. I'm going to draw a nice new straight line down here. Okay. And if I put my three angles off my triangle together along this line, so there's one, there's another one, now the third one should, look at that, absolutely spot on. So have a think, what does that tell us? Now, were we in the classroom, we'd sit and have a nice discussion about this. If you want to have a think about it, please pause. But what it shows us is that we've got the angles of a triangle fit to make a perfect straight line. And we've just proven that a straight line is 180 degrees. So that tells us that any the three angles out of any triangle must always add up to give us 180 degrees. And it doesn't matter which way I put these. I could have gone like this. Could have done it the other way around. They'll always make that straight line. Okay, I've not done anything special. So we can put that knowledge to good use. And I've got some examples here, so please stick those into your book, okay, with maybe a nice little explanation of what it means, okay, nice explanation of what we've just proven there. And I've put two examples together here. I'm going to get a different colour pen. So if I know that this angle is 70 degrees and this angle is 40, but I don't know what y is. I've called it y, just a variable, because we don't know what it is. But what we just proved was that they have to equal 180 degrees. So what I'm going to do 70 add 40, which equals 110. And that's the sum of these two angles. Remember, sum is when we add them together. then I'm just going to have done this the wrong way around, really, haven't I? I'm going to do 180 degrees, which we know they have to add up to all together, subtract the 110 I know we've already got in there, which is 0, 7, and that's going to give us a 0 as well. So 70 degrees. I'm going to just squeeze that in there, look, 70 degrees. And I'm not going to tell you, but I hope you guys can tell me what kind of triangle that we've got there. We've just proven a particular type of triangle. So there's the first one. Here's another example. If you write these two examples into your books, do these as sketches. They don't have to be perfectly, please do them with a ruler of course, but they don't have to be perfectly measured out. Just do them as a sketch. So when we do a sketch in maths, we draw it with a ruler and a pencil, but we label things, okay? It doesn't have to be drawn accurately. We just say this is 70 degrees. It might not be exactly, but as long as it looks about there, this is our 70 degrees. So draw a sketch of that one in your book. And then here's a second one. I'd like you to get a sketch of this one as well, please. So this one here, we know a right angle is 90 degrees and this one is 30. So we've got 90, add 30, 0, 12. Okay, so that's 120 degrees altogether. And then if we do our 180, subtract the 120, we get 0, 6, 0. Okay, so this angle here, Z, I'm going to put a little arrow in there, I can't quite fit it in, is 60 degrees. I'm uploading some worksheets for you to have a go at. You only need to do the first page, but if you'd like to do more, brilliant, please do. If you've got any problems with any of this, is anything that you've not quite followed, get in touch and I can send some more examples or a bit more advice if you need it.